Let's continue with example 1. Prove a polynomial identity. How can you prove the sum of cubes identity? A cubed plus b cubed equals binomial a plus b and trinomial a squared minus ab plus b squared. To prove an identity, start with the expression on one side of the equation and use properties of operations and polynomials to transform it into the expression on the other side. So basically, you just need to simplify and you need to solve it so that you see they're equal to each other. So you can start with the right side, so you can actually solve it. So you can multiply them out. A times the trinomial and b times the trinomial would give you the identity, and then you multiply them out, use the distributive property, group like terms and add them together, and if you combine like terms, you'll be able to prove that this trinomial is actually the same as a cubed plus b cubed. So they're identities. So just like this, we're going to prove the difference of cubes identity and try one. So let's pause the video and see if you can prove the difference of cubes identity. Remember that the difference of cubes is a minus b times a squared plus ab plus b squared. So see if you can prove that they're equal to each other. Okay, are you ready? Alright, so we're going to multiply this out, right? So a times a squared plus ab plus b squared plus negative b times a squared plus ab plus b squared should be the same as it should be an identity, right? They should be equal. So using distributive property, you can write that it's a cubed plus a squared b plus ab squared minus a squared b, and then minus ab squared minus b cubed. And then you're going to combine like terms. You can group like terms first, but a cubed is just a cubed by itself. And then a squared b, we have a squared b minus a squared b, so it's gone. And then ab squared minus ab squared, so they're gone, right? And so we just have a cubed minus b cubed. So we have proven that they're equal to each other. Okay, that was example 1. Let's move on to example 2. Use polynomial identities to multiply. How can you use polynomial identities to multiply expressions? Let's look at some examples. Look at part A. So we have the entire binomial squared. It is a binomial, so the entire sum needs to be multiplied. So this means you have 2x squared plus y squared, y cubed, all of that multiplied by itself, 2x squared plus y cubed. So then originally you would have to use the FOIL method, but we know that there are polynomial identities, right? So if you use FOIL method, then you have to actually have more steps. But if you know the square of a sum identity, we know that a plus b squared is equal to a squared plus 2ab plus b squared. So first, let's identify a and what's b. So a could be 2x squared, and then b could be just y cubed, right? So we can just make that a and the other term b, and they're all squared. So then we can just use this form and plug it in. So a is 2x squared, so you just put 2x squared plus 2 times ab, so 2x squared times y cubed, and then plus b squared, so y to the cube power, all of that squared, and then you just simplify. Then you have much less steps than multiplying them out one by one and then combining like terms. So then if you know the form, if you know the identity right away, you can save some steps. Okay, so then it's equal to 4x to the 4th power plus 4x squared y cubed plus y to the 6th power. In the same way, even if we don't have variables, if we just look at the numbers, it's a little bit of a big number, then it really helps if you know these polynomial identities and how to use it for the constants as well. So if you have 41 times 39, we can rewrite the expression in terms of a and b to use the difference of squares identity. I know it may look like it's more steps, but actually if the numbers get even greater than these, then you will be able to save a lot of time if you don't have a calculator, right? So yeah, use the difference of squares in this case, where you have 40 plus 1 and 40 minus 1. So the goal is to find a and b, where you can write it as a plus b times a minus b. Now, how do you know which identities to use? Well, you need to look at the identities here and see which one would be closer. Do you think you can rewrite it as a squared minus b squared, or do you think you can write it as a plus b times a minus b? Or do you think you could write it as you just have to look at the forms and be comfortable with it and see how you can rewrite it so that there is a form that you can write where you have an A, you have a B, and it matches the form. In this case, 41 and 39 could be written in terms of 40 plus 1 and 40 minus 1, where you have both numbers that are the same, 40 and 1, right? Because both numbers are only 1 apart from 40. So then you can use the difference of squares identity and just say, oh, then it's equal to 40 squared minus 1 squared, because it's going to equal to a squared minus b squared. So that you can just multiply 40 squared first and then subtract 1 from that, and you'll get 1,599. And this may take a lot longer time if you have a bigger number and you wanted to multiply all of it by yourself. And if you get used to it, this is actually it's not going to take long. So if this happens in your mind, then when you're comfortable with it, it should come to you in seconds or just a second, right? Yeah, so you can practice using the numbers if you're not entirely comfortable with using the variables. But it is very important that you get comfortable with all of these polynomial identities. So please remember these. If not, please write it down in your notes and make sure you have a reference when you see problems. Let's look at try number 2. You're going to practice using polynomial identities to multiply the expressions. So see if you can identify a and b and simplify them or multiply them using the identities. Pause the video and come back when you're ready for answers. Okay, are you ready? So look at part A. Do you see any forms here? Yeah, we see a difference of squares, right? A plus b, a times a minus b. So your a could just be 3x squared, and then your b could just be 5y cubed. So then, using the difference of squares, so we're gonna use difference of squares to solve this. And knowing that a plus b times a minus b is equal to a squared minus b squared, we're going to identify a first. A is 3x x cubed. and then b is 5y cubed. Okay, let me zoom out a little bit and see if my pen works better. And we know that this is going to be a plus b times a minus b is equal to a squared minus b squared. So this is the a plus b times a minus b. So we know this is going to be equal to a squared minus b squared. So then we just make sure that we plug in the right numbers squared, and then we square them, and you're gonna get the squared 9x to the 4th power minus 25y to the 6th power. So this is your final answer. That is a 9, not 4. Okay, and look at part B. This is 12 plus 15 squared. And how can you rewrite this with a form that you may be able to write? Can you write this as difference of squares? I think you can also use difference of squares for this one as well. Yeah, let me type. You can also rewrite this with the difference of squares. How can we rewrite using a and b that are the same numbers? So 12 could be 13 minus 1. 15 could be, So 12 could be 13.5 minus 1.5 if we want to do that, right? And 15 could be 13.5 plus 1.5, where we have the same a and b, right? So we could use that one, or this is actually already a square of a sum. So actually, I think it's better to use the square of a sum. I think difference of squares will be more work than square of a sum. So let's change this to square of a sum. The square of a sum is when you have a plus b squared is equal to a squared plus 2ab plus b squared. So then you already have a and b, right? So square of the sum, tells you that you can just have a is equal to 12 and b is equal to 15. And then you multiply them by using the square of a sum. So that's gonna be a squared plus 2ab plus b squared. So just using that, you can plug it in. 12 squared plus 2 times 12 times 15 plus b squared, 15 squared. Okay, and then if you simplify them, it's going to be 144. If you multiply them out, it's going to be 144, and then 15 times 12 is 180, and 180 times 2 is 360. So 360 plus 15 squared would be 225. And then if you add all of them together, it should be 729. Okay, let me double check. Yeah, 729. All right, so using square of a sum, you can just plug it in like that. Or you can add 12 plus 15 and get 27, and you can square 27. But this is a good practice for you to get used to the polynomial identities. So I think it's a good idea to practice using just the constants if you're not entirely comfortable with the polynomial identities. All right, so that was those were examples 1 and 2. We're going to continue with the next example in the next video. Bye.